Good. All right. So again, standard form. Here we go. Input. Go ahead and write your L/D. We have a couple of language of the discipline words and your gate icon. Draw your lips. Language of the discipline. And of course, our first word is standard form of a linear equation. So we're just going to write standard form. Okay. And standard form is AX plus BY equals C. Common. Where A, B, C are red and A and B are not 0. And if you want to go ahead and please highlight that formula. Okay. Next one. Yesterday we learned what the y-intercept was. Today we're going to learn x-intercept. X-intercept. And the x-intercept is the x-coordinate that crosses on the x-axis. The x-coordinate that crosses on the x-axis. So that point goes on the x, the horizontal line. Yesterday our y-intercept went on the vertical line. So I'm going to go ahead and draw a quick visual for you so you can see. Please draw this in your notes. It's just really small. Doesn't have to be big. If I have a point on my vertical, that's a y-intercept. If I have a point on my horizontal line, that's the x-intercept. Okay? Very simple. We good? Yes?
Yes.
Thank you. All right. So, finding the x-intercept is what you have to do. So, you're going to have questions on your homework that ask you to please find the x-intercept. What do you need to do for that, finding the x-intercept? You need to substitute 0 for y. So when they ask you to find the x-intercept, all you do is put 0 in the place of y and then solve. And then finding the y-intercept, what do? The exact opposite. You substitute 0 for x. Very simple. Super, super simple. So let me show you how to do some of these problems with some modeling. Let me look this up a little bit. Okay, example. Put example number 1 on your paper. Find the x and y intercepts are the directions, and those are the directions you're going to see on your homework. Find the x and y intercepts. Thank you for writing that down. Find the x and y intercepts. All right, so let's look at problem A. They give us 3x plus 4y equals 8. And I'm going to put a little note for you guys on the side. That's standard form. It's This problem's already in standard form. So they want me to find the x and y intercepts. Okay? So if I look, the first thing I'm going to do is I'm going to find the x-intercept. I'm going to abbreviate x-intercept. So that's the first thing I'm going to find. So I'm going to put a little cloud around my x-intercept. Now I'm going to go back to my language discipline. To find the x-intercept, I need to substitute 0 for y. Oh, I can do that. So let's write the problem down. 3x plus 4y equals 8. Now I need to substitute in 0 for y. Easy. 3x plus 4 times 0, because I'm replacing y with 0. Make sure everyone's paying attention. Equals 8. So then I solve. 3x plus 0, because 4 times 0 is 0, equals 8. So that means 3x equals 8. Last thing I do is get x by itself. I divide by 3 on both sides to isolate the variable. My 3's cancel because 3 over 3 is 1, so that's like 1x. X equals 8 over 3. I found the x-intercept. So again, write down the problem. To find the x-intercept, you replace y with 0. But it doesn't ask me just for the x-intercept. It asks me for the y-intercept as well. So I need to find that. So when I look back at my language of the discipline, it tells me to find the y-intercept, I need to substitute 0 for x. Easy. I can do that. So I'm going to write the problem down first. 3x plus 4y equals 8. Now it tells me I need to substitute 0 for x. 3 times 0 plus 4y equals 8. 3 times 0 is 0 plus 4y equals 8. Which means it's just 4y equals 8. Now I just need to isolate the y, get the y by itself. So I'm going to divide by 4 on both sides. My 4 over 4 is like 1. 1y is y. Equals 8 divided by 4 is 2. So my final answer is 8 over 3 is my x-intercept, and 2 is my y-intercept. Final answer. Very simple. All you do is replace either one with 0. Now, if you get a fraction that you can't reduce, you can leave it in improper fraction form. But if you can reduce it, you have to. You don't have to turn any fraction into a mixed number. You can leave it in improper fraction form. Yes?
Yes.
Thank you. Okay. Let's try letter B. I'm going to move this up if that's okay with everyone. Negative 2x plus 3y equals 6. Again, I'm going to tell you guys that that's already in standard form. Sometimes you won't get it in standard form. Okay. I have to find my x and y intercept. Okay, cool, pretty easy. So my x-intercept, let's find that first. So I'm going to write down the problem. Negative 2x plus 3y equals 6. Again, when you find the x-intercept, you replace y with 0. So I have negative 2x plus 3 times 0 equals 6. Well, 3 times 0 is 0, so I'm left with negative 2x equals 6. To isolate the variable, I'm going to divide by negative 2 on both sides. I'm going to write it over here because I ran out of space. My x equals 6 divided by negative 2, negative 3. So I got x. That was easy. Now I need to find my y-intercept. So I'm going to put that on the other side. And again, when you find the y-intercept, you replace x with 0. So I'm going to write down the problem. Negative 2x plus 3y equals 6. Let me zoom for you guys a little bit. So I'm going to replace x with 0, so that's negative 2 times 0 plus 3y equals 6. Well, negative 2 times 0 is 0, so I have 3y equals 6. To isolate y, I divide by 3 on both sides. Y equals 6 divided by 3 is 2. So what's my final answer? X is negative 3. Y is 2. Even on your test and on your homework, when they look for final answers, they want it like this: X semicolon Y. But you found it. So make sure your answer ends up like that. Pencil up when you're ready. Awesome. Okay, example 2. Don't worry, there won't be as many examples as yesterday because we're just running one section. Graph each equation using intercepts. That's your direction. Graph each, thank you for writing the directions, equation using intercepts. So you're going to see this on your homework too. So not only do you find the y and the x like what we did in example 1, but when you're done, you graph it. Okay? So let's look at example A. We have 2x plus 3y equals 12. Not a problem. Let's find the x-intercept first. Okay, so to find the x-intercept first, let's write down the problem. 2x plus 3y equals 12. Now I need to think to myself, if I'm finding the x-intercept, I replace y with 0. So I have 2x plus 3 times 0 equals 12. Good job taking notes, guys. Awesome job. So then 3 times 0 is 0, so I'm left with 2x equals 12. To isolate the variable, get x by itself, I'm going to divide by 2 on both sides. My 2's cancel because that's like 2 over 2 being 1x, which is x. 2 divided by 12 is 6. So I found the x-intercept. Easy. Now I'm going to go over here and find my y-intercept. And write down the problem first. And again, knowing what my notes say, in order to find the y-intercept, I replace x with 0. Don't get confused on your homework and replace the same number or the same exponent. I mean the same variable. Goodness, I can't speak today. So I replace x with 0. 2 times 0 is 0, so I'm left with 3y equals 12. Because 2 times 0 is 0. That's gone. Now I isolate the variable. I divide by 3 on both sides. Y equals 4. 12 divided by 3 is 4. Miss Graham, that's so easy. Well, it's not over. They ask us to graph it. Okay? So what you're going to do is... I'll see if I have any space over here. You're going to graph. And I'm going to graph by 2, so I'm going to make it about 5 long. So I'm going to draw my graph. I'm going to label it 2, 4, 2, 4. Actually, I lied. I'm going to do 2, 4, 6, 8, 2, 4, 6, 8, -2, -4, -6, -8, -2, -4, -6, -8. Okay, so once you've made your graph, all you have to do is place those points on the line. So what is x? My x is 6. So I'm going to go up to the x-axis. X-axis is the horizontal. Now I'm going to put a dot on 6. And the y that we found was 4. So I'm going to go on the vertical axis and put a point on 4. And then guess what? There's your line. Bam. That's it. That's all you have to do to graph it. Easy, right? That's it. Put the dot on each one, connect the line. Now, I give you an example of that. What if I gave you something that looks like this? Now, that's not in standard form. What do I do? Well, we know, learning from Slope Dude, that anything that x equals is horizontal or vertical? Horizontal. It's vertical. It's pointed on the horizontal line. Let me show you. So, I don't need to find a y-intercept. There is no y in this problem. So all I need to do is graph. So I'm going to graph. I'm going to make it about 4 to 5 long. Probably 5. So I'm going to label this 1, 2, 3, and 4. Positive 1, positive 2, positive 3, positive 4, negative 1, negative 2, negative 3, negative 4, and negative 1, negative 2, negative 3, negative 4. Now my x-intercept is negative 3.5 or 3.5. So I'm going to go to my x-axis. I'm going to go 3.5, 1, 2, 3, halfway between. So Ms. Graham, I don't know where my line goes. If you have x equals, your line is always going to be vertical. And that's your line right there. That's it. Sorry, my line's not very straight. That's it. So, make yourself a little note on the bottom. All x equals blank, whatever it equals, will be vertical. Write yourself that note. If you get anything that says x equals blank, your line's going to be vertical. So then my next example is going to look pretty similar, except guess what? This one says y equals 6. And I'm sure you smarticle people can already probably figure out what the line is going to look like. But let's see. Again, there's no x-intercept for me to find, so I can move straight to graphing. Since the number is 6, I'll graph by 2s. 2, 4, 6, 8, 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8, and negative 2, negative 4, negative 6. Negative. Sometimes it's just easier to graph by 2s or graph by odds, whatever you want to do, 5s. Okay, well, y equals 6. So it's on the y-axis, which is this vertical line here. So if x equals 6, I'm going to put a dot on the 6. And guess where my line goes? Straight through it horizontally. So if you ever get anything y equals something, it's going to be horizontal. So again, write yourself the same kind of note at the bottom of that one. All y equals blank, whatever y is going to equal. Hi, Texas. Please welcome Mr. Morales.
Welcome to the University of Texas, Mr. Morales.
Thank you, class. I really apologize for the interruption, but my answer book for the workbook for math has disappeared. So do you happen to have an extra workbook?
Yes. Okay, go ahead and write that note. All y equals will be horizontal.
Thank you
You're
very
welcome.
much.
All y equals will be horizontal. How do you feel about that? Not bad, right? Easy? I can move on then?
Yes.
Oh, cool. All right. All right. Example 3. Your directions say to write in standard form using integers. Huh? Don't worry. It's not hard. I'll show you and you'll be like, oh, that's easy. Okay, so look at example A. They give it to us in slope-intercept form. Y equals 4x minus 11. Now, it wants us to write in standard form. So let's look back at our notes. What does standard form look like? Standard form is ax plus by equals c. So do I need to have x and y on both sides? Most definitely. Okay, so write yourself a note. Put x and y on both sides. I'm going to write myself a note right here. Put x and y on both sides. Put x and y on both sides. Okay, I can do that. So, okay, y is already over here. So I'm going to move x to the other side. So I'm going to subtract 4x from both sides. Algebraic problem. That's a positive 4x. I'm subtracting 4x from both sides. So my positive 4x and my negative 4x cancel out. So I'm left with negative 4x plus y equals negative 11. And then box your answer because it's in standard form.
Yeah, A.
Bless you.
Nope. Sorry.
No, that's okay. Thank you.
Okay? So you'll know your answer is correct when both x and y are on both sides and it looks like this. Yeah, let's try example B. This one has a fraction in it. Y equals 3 over 4x plus 2. Well, Miss Graham, how do I get x on the other side? Well, to make your life easier, let's get rid of that fraction, yes? So whatever you multiply by on both sides, right now I'm going to multiply by the denominator, 4, on both sides. Multiply by the denominator. So now I'm left with 4 times y, which is 4y. Now this is kind of like 4 over 1, so these 4's cancel out. I'm left with 3x plus, because you're distributing, 4 times 2, which is 8. So I got rid of that fraction by distributing the 4, multiplying by 4 on both sides, basically, and getting rid of it. Wait. So now, in order to get x on both sides, I'm going to subtract 3x on both sides because it's a positive. Positive 3x and negative 3x cancel. I'm left with minus 3x plus 4y on this side equals what's left over? 8. Now, standard form does not have fractions, so that's why we have to get rid of that first. Okay? Let's try another one here. Let's put it on the side, example C. Just to give you another example. I have y equals negative x over 5. So I'm over here now. Okay, I'm going to multiply by 5 on both sides to get the x by itself, not as a fraction. Okay? So multiply by 5 on both sides. Whatever you want to do, parentheses. 5's cancel on that side. 5 times y is 5y equals negative x. Can I leave it like that? No. I need to get x and y on both sides. Wait a minute. I'm going to add x to both sides, Ms. Graham, because this is a negative x. Now I'm going to get x plus 5y. But that's not standard form. It has to be equal something. When it's like that, equals 0. There's nothing on that side. You put a 0 there. Standard form. What's your answer? Let's try one more, fraction 1, and then we will move on to the last example. Let's do y equals negative 4/5 x plus 6 over 5. To get rid of the fraction, get rid of the divided by 5, I'm going to do the opposite, multiply by 5 on both sides. Okay? So I'm going to multiply this by 5 and multiply the other side by 5 on both sides. Okay? So, but because I multiply by 5 on both sides, that gets rid of the 5 in the denominator. So I'm left with 5y equals negative 4x plus 6. When you multiply by that, it gets rid of it in the denominator. Okay, well now I need to get x and y on both sides. So I'm going to add 4x because there's a negative 4x over there. I'm going to do the opposite and add 4x to both sides so that I can get x and y together. So I have 4x plus 5y equals, what's left over on this side? 6. Done deal. And our last example is a word problem. Good job taking notes. We're almost there. Please write it with me. Write an equation in standard form to find the number of minutes someone who weighs 150 pounds would need, we're almost there, keep writing, to bicycle, so this person wants to ride a bike, to bicycle and swim laps in order to burn 300 calories. So we have someone who weighs 150 pounds. They want to burn 300 calories. So we want to try to figure out how to write that in standard form. Psst. Alex. Push it down. Thank you. Yay. Okay, so, that was funny. They give you a little graph. They give you the activity of a 150-pound person. And they give you the calories burned per minute. So if they bike, they need to bike 10 minutes. They get 10 calories for biking per minute. If they bowl, they burn 4 calories a minute. And if they swim, they burn 12 calories a minute. So write yourself a note that we're gonna let X, we're gonna determine what our X and Y is. You can pick. I'm gonna make X our minutes biking. And I'm gonna let Y be our minutes swimming. Why do I pick swimming and biking? Because that's what it says right here. How long if they bike and swim. If they bike and swim. So I let X be minutes biking and Y be the minutes swimming. So we determined our variables. Okay? So the first thing you always need to do is determine what you're going to make X and what you're going to make Y. Alright, so I can write the equation now. What's the equation for standard form again? It's AX plus BY equals C. Alright, so X is going to be the amount of minutes they bike. So they burn 10 calories a minute. So I'm going to let that be 10X. That's how many calories they burn. 10X plus, that's swimming, biking, 12. Biking first, then swimming, 12Y equals 300. That's how many calories they're going to burn. So again, let me label it for you. This is biking plus swimming equals the calories that they burn. Biking plus swimming equals calories. And now, so you're ready, you can go ahead and stop.